And I think that's pretty much it. So you good to go?
Yeah.
All right. Well,
Ready to go.
thank you very much for speaking.
All right. Thank you, everybody. Hello, Michael Leonards, and this is Intro to API Design with NestJS. About me, again, Michael Leonards. I'm an engineering manager at Artera Inc. Used to be called Well Health Inc. We're telecommunications in the healthcare industry. I transitioned into web dev in 2018. Really love learning and teaching. Part of the reason why I got into this is I just love there's so much to learn, and also why I keep doing events like this. About me, I love video games. My LinkedIn, if you want to get in contact with me. This is my husband. We went out to Ted Laird to do some orchids in some vases. This is my fur baby Dahlia. She's a little bit bigger now, but it's still pretty small. And then we just had our first baby, Penelope. This is pumpkin carving a couple of months or so ago.
You know my daughter's name is Penelope, right?
No,
Yeah.
God, it's become really common. We looked at it, we were like, Penelope's not that common. It's like number 6 right now. So it's just one of those waves where when she goes into school, everyone's gonna be named Penelope. Who knew? But at least she'll have the unique last name, Leonards. All right. Yeah, that's me. Happy to answer more questions later if you're curious. So NestJS, it's an API framework that's built with TypeScript out of the box. It has a modular design, so it has good organization scalability. It works with dependency injection, so think about C# and Java, or if you use JavaScript, Angular also uses a similar dependency injection with modules and components and stuff like that. It uses Express.js under the hood, but it is adaptable to different libraries like Fastify. It's ready, microservices ready out of the box, and you could also build it with GraphQL if you'd like. You could build resolvers using its own NestJS package for that. That's because it has a rich ecosystem to integrate with, and libraries and toolings. If you've been in the industry for a while, you probably experienced more opinionated, everything included kind of frameworks, and maybe more build it as you'd like. I see like Angular more, batteries included, opinionated, React more, build it as you like. This is quite an opinionated framework with a lot of the functionality that you need included. So it has ways that it wants you to do things, and it has it does that really well for you. It also has CLI tooling similar to Angular, where you can create routes and create controllers and stuff like that. So I'd like to take a moment for everybody to think. What do you like about this list? Do you love dependency injection? And I'm like, heck yeah, I get to see that in API design in JavaScript. Or what do you like or dislike about this? Go and talk with the people next to you. What do you think? All right. So, what are some of the things that you like about this? Things we liked or loved, even. GraphQL. People are doing that. I love TypeScript. Yes, TypeScript and GraphQL. What about like GraphQL code generation on the front end? We have that right now. Hasura we use with NestJS, and God, love the code generation that you get with that. Any other dislikes or any fears out there? Yeah, you familiar with that? Nice. Cool. All right. Well, let's go ahead and keep moving on. This is not. Oh yeah. This is the slide. So we're going to be looking at the code through GitHub, VS Code, and Postman. I'm going to be hopping around through some commits, and then also running the server and hitting it with Postman. This is where the server is going to be at. The course that this is based off of, pro tip here, bought this course, like a year ago, February, and finally was like, okay, I'm going to start it. I'm going to do it. And this talk, Justin was like, we need somebody to present in November. And I'm like, well, I'm working on this course. Might as well like really double down on it and commit to doing this talk. So thank you all for being here and being my motivation. If you'd like to, this NestJS Zero to Hero course was good, but NestJS has a course itself that is very well reviewed. So you could go straight to NestJS, their courses directly. So I just want to give a brief primer about REST APIs. You in your API design, you'll have an endpoint where you have requests coming in and responses coming out. Something handling where your routes are going to for your different endpoints. And then you have a controller. In this case, we are putting our validation in our controller level that you'll see in this application. And then you have a service layer, which is where a lot of the business logic goes. If you need to filter on things or compare this to comparing that and making sure you join this stuff so that you get all the stuff you need back for your endpoint. And then you have your data access layer, which we call repositories in this framework, but there's different methods to access your data. In this presentation, there's going to be two different ways that we're going to go about this. The first one is going to be using a combined service database access with an in-memory array. So there is the database is going to be an array that we're adding things to and removing things from. You could imagine problems with this whenever you restart the server, you lose that array. So that's one problem that we have when we're developing. And so then part two is going to go over using type ORM and Postgres. Type ORM is a JavaScript package that lets you write JavaScript methods to access data and whatever data source it has adapters with, and it has adapters to both Mongo, Postgres, and other SQL-like and NoSQL databases. If there's ever any questions, feel free to ask. I don't promise to have the answers, but definitely welcome to receive the questions. All right, so the scope of this presentation, we're going to talk about app setup and NestJS structure. Excuse me. We're going to talk about creating controller endpoints, providers and service injection, creating models and using DTOs, data transfer objects. We're going to talk about NestJS pipes and how they're used for validations. And we're going to talk about data access with type ORM to our Postgres database. If you're more of a visual person, this is what ChatGPT produced for me as a clip art infographic. And a few others. I gave about 11 tries and I was like, please just use only the words I'm providing you. And it was like, no, I'm gonna make up words.
No, this is graceful.
Like Dematabia. It gets so close. Database.
Boss.
Right, so let's go ahead and hop into the code. So this is our repository. I'm gonna go ahead and zoom in so you can see clearer some of the overview. Now we're not gonna actually go over the app setup. It's pretty straightforward. NestJS, like I said, comes with a CLI tool, so you can install the CLI tool using npm, and then just create a new Nest project. And that will scaffold you a basic project for NestJS. And then you could also use the CLI further to generate, with this -g, you can generate controllers, generate models and stuff like that using the CLI. Now, to start out with, we're going to be looking up this startup app one endpoint. And it stays pretty well zoomed in. So this basic app, let's go over the app structure first. So I'm going to zoom in here. we cleared out some of what was originally scaffolded and just included this app module. This app module is mounted here in the main.ts, kind of like your index file for this application, where it bootstraps the application with this Nest factory create. You could do extra things in here, like where we add Swagger, we added in here. Later on, we're going to add some validations in here as well. And our module you'll see is importing this tasks module. This tasks module contains a controller and a service. And our controller has a tasks endpoint within it that only has get all tasks. And our service calls into get all tasks with just getting this array of tasks. So that's our basic controller that we've set up here at the start of this application. I'm going to go ahead and start this real quick. And then I have with Postman different methods here. We're going to do this get all tasks endpoint to just get here at this task. And we'll see that we get an array of tasks. Now already, and just to show this working, I'm going to go ahead and put a few other things in here. And go ahead and send that request in again. Don't have any other. Did I do npm run start dev? Maybe I forgot the dev part, which puts it in watch mode. All right, so there we have our array of tasks. And so that's what I meant by in-memory database. We're just using this array, and we'll interact with this array using our API. And to set all this up, I talked about dependency injection. So this task service, you'll see in this controller is not instantiated as a new instance. You'll see this constructor private task service. This is where the service is injected in as a dependency through the constructor. And in order for that to work, we have to have this injectable decorator to make it able to be provided as a service. And then we have to put it in our providers on the module. So here in this module, we're saying, hey, we're going to be giving task service to any of the controllers or any of the any of the other classes below it. We can inject those as providers. And that is the dependency injection portion of that task service. All right, so that's not very exciting, right? We just have our controller with a get endpoint at this tasks URL, and this is where we define what our URL is that we're going to be hitting. So let's go ahead and take a look at the next commit here of add create task. For this endpoint, you see that we decorate this create task endpoint with a post decorator. This is our way of telling NestJS that we want to use a post request for the create task. And then you'll see these at body decorators on the parameters that we're passing into create task. And this says that we want to pull those parameters off of our JSON body that we're sending in. And this also, the controller calls into our task service to create our task. And then in our task service, we go ahead and create that create task method or function and pass in the title and description, create a new task, and console log it, because I forgot to take that out. Push the tasks to our array, that simple array that we're using in memory, and then return the task that we created. So we skipped over the model. We have this task model that we created. If you're familiar with TypeScript, just creating that task model to use here, and then an enum for our task statuses. So let's go ahead and check this one out. So now we have our service and controller with our create task endpoints. And I'm going to go ahead and post apples dose. And you'll see it didn't create it with the title. That's because I was testing this out later for validation when you pass in something different. I'm gonna say dose task. It will have created both of those, but we'll see when we get all, only one of them will have a title because we didn't provide that on the JSON payload. So that's a good example of where you'd want to do validation. Make sure that your user, whatever the client is sending in your request, that they provide the title. If they don't, then you could go ahead and validate all that. All right. And feel free, any questions or comments, feel free to stop me. Next, we created DTO, a data transfer object. And this is something that's used instead of, you see here for this body, instead of calling out exactly what we're expecting in the body as parameters, we create a model to use here, this create task DTO, with the parameters that we're expecting to come in. This way, if you're using that model in multiple places, you have one centralized place to locate it, and maybe you have some dumb methods here to do some data changing it on your way in. And then we could also use that create task DTO on the service to and spread it on our task to add all the methods to the task. I'm not going to go ahead and check that one out. Now for our delete task, similar to what we've done before, we go ahead and use the @delete property from NestJS. If you remember, we use the post on the create endpoint, and that's because we want to use a delete method to pass in the UUID to delete that task from the array. Now, instead of body here, you'll see that we use param. That's because params is coming in as URL parameters. And we tell that URL parameter of ID here by putting in that string of :ID here on the delete decorator. So for this delete endpoint, this tells us that we're expecting an ID. On the params, we pull off the ID parameter to call the task service. And then we go ahead and delete the task by filtering the array where tasks don't equal the task that where the tasks filter it so that we return the task where the task ID is not the ID that we're passing. So just to show you that, I'm gonna go ahead and get checkout. So now we have our delete controller endpoint. And this is the downside of using the in-memory database. Every time we restart the server, our data doesn't persist. So let's go ahead and post task. I'll go ahead and grab that UUID. And just to show that it exists, I'm going to use the get all endpoint. We have that task in our array. And then we'll go ahead and call the delete with that. Oops, I copied instead of pasted. I think I'll create a little more space for myself. We don't need that. All right, we'll go ahead and send. 200, okay, and when we get all. We still have it.
I think you copied.
Yeah, it's still the same.
Oh, it's still the same, okay. Yeah, I was gonna say, we should have gotten a 204.
It's still two.
Yeah. All right, we had deleted. Maybe it's,
It's 200 until you switch it over. I don't think you have the status code.
gotcha. All right, so moving along through our endpoints here. We also have an update status, so this, I think I buried the punchline, but this is like task to-do list, where we're creating different tasks we have to do. We have the title, description, and then the status, different options on our status in our enum that we saw of open, in progress, or done. And so we want to create an endpoint here that allows us to update. So we're using the patch method for this one. Where the format of the URL is going to be that parameter of ID and then /status. So this ID is going to be coming in, but we're also going to be taking in the body with the status. So the parameter is going to be on the URL of an ID, and then in the body we're going to have the status. And similar to our other methods, we use that tasks array. We find the task that we want to alter and then update the status. So I'm going to go ahead and post again. So we have dose task that's open. You can go ahead and update this. Oops, I don't want to delete that status. I just want to update the UUID, and we'll say in progress. Dose task is now in progress, and you can get all and see that it is in progress. Again, with validation, without validation, you can just put in whatever you want, and it updates the status. And this is where sometimes TypeScript gives us a false sense of safety. We claim it as an enum, but it doesn't really matter when it comes down to it. And compiled into JavaScript, it'll accept any value there. So we'll add validation here in a bit. All right, and then our last endpoint is to filter our tasks on a status and a search. And with this one, we use tasks filter DTO again. And if we have either of those query parameters passed in, we'll be, let's see, this one, no, get all tasks. Oh yeah, this one, we'll be passing them in as query parameters, like so. If either of those query parameters are passed in using this query decorator, we'll go ahead and use the task service to get tasks with filters, and then do some logic here. If there's a status, then go ahead and filter the tasks on the status. If there's a search, console log again, just to make sure it's working, and then filter the tasks on the search. You'll notice in this case, we do both the description and the title. We do not do uppercase or lowercase, which is something that we'll handle when we do the type ORM. All right, so let's go ahead and check this out. And we'll create our second task. Create our first task. So now we have two tasks here. I'm going to go ahead and use this filter method. Right now, if I leave these parameters, we're going to get neither, right? If we do search, I think it was task was in both of them, right? We come back both. If I search for dose, I'm just going to get the second one. And then we can also do in our status open, we'll get both of them. But if we do done, time. We'll get none, just to show, let's go ahead and update this to have that status of done. I hope I copied one that actually. Yep, okay. And then we'll filter by done and get just that done task. So that's real quick, these basic endpoints for this NestJS application: create a task, delete a task, update, and get with status and searchable, all with an in-memory array. Nothing too fancy for where that's saved at. All right, for the validations, there's two parts to this. One is where NestJS offers the pipe validations, and this is explained pretty well in its documentation, that on the client side, you might have some filtering and logic going on, but on the API side, they call them pipes, that the data comes through before it comes into your controller. And there's this built-in validation pipe class that's provided that will allow you to do a lot of validations. And the validations that we're going to be using are from class transformer and class validator. So where we set up the application in the Bootstrap is where we apply this global pipes. You can apply pipes, I believe, at the this global level. You can apply them at a controller level, or you can apply them on individual parameters going into your controller. So you can specify where you want to apply different pipes at different levels. And this simple case is just looking at is not empty on the create task DTO, because we don't want somebody to create a task without a title or a description. Well, there's my console logs. So now that this validation is being applied, to our create task DTO, when I try to create a task, I try to do it with a title and description blank. We'll get a 400. Title should not be empty and description should not be empty. Messages that you could customize, pass them back to the user if you want, but they're just a generic from the validation package that we're using. Right.
The validator and transformer libraries, are those like part of Nest, or is that a separate thing? Do they recommend using these?
This pipe, this validation pipe is part of Nest. And class validator is not part of Nest, but they do recommend it or offer it that this uses the class validator package to validate on. And so they kind of go hand in hand. The validator pipe is from Nest, whereas the class validator is from a different creator. Yeah, there's a lot of different validations types of that you can do. Oh yes, we'll just go ahead and check this out and take a look at some of the validations because I got lazy on my commit. So different validations that we apply for our get task filter. This was actually a mistake I tried to edit in my Git history, but it didn't work. So this is how it's supposed to be for status, right? Should be optional. We don't want to require them to provide that query parameter. And we want the task status to be one of these enums. We want it to validate and say like, hey, well, I'll just show you. this might grow, yeah. So if we do done with a D, it'll say status must be one of the following options from that enum. But this is where I made the mistake. This was supposed to be not as optional. It's supposed to be, or it was not supposed to be as empty. We want them to not provide that task if they don't want to. And so remedy that mistake. Won't be in the Git history if you go and check this out, but that's what that is. And then on our update task, we want to make sure that we update with an enum. We saw that earlier where we had this, we updated with a value that was not one of the enums, and it got upset with us. Do I have any? I don't have any in here. Let's go ahead and create one. Oops. So now when we try to update this task with a value that's not part of the enums again, we'll see that it validates that and tells us that it has to be one of those three values. There's a few other validations that we do at the service level that I'll show you. And that's the not found exceptions. So we updated this so that the get task by ID, if it doesn't find the task, it throws that not found exception. And then we use this get task by ID in several of our other services. When we update the task, instead of finding it again, we use get task by ID so that we have that validation there, and the same with the delete task by ID. Right. So that's it for the validation side of things. Now we're going to move on to using Postgres and type ORM to wrap up the talk here. If I run this command now, I think I already have the Docker container created. So I'm going to go ahead and maybe it's actually already running. Yeah, so it's already running. The tutorial has you use pg admin to create your database. You could, like, if you do this programmatically, you want to run it like a migration to create the database. And then to set up type ORM, we're adding our type ORM and Postgres package, and it's injected at the module level here within the app module, that we have this type ORM module connecting to our database task management using our username and password that we created the database with the Docker command. I'm gonna talk about a few and then jump ahead here to actually interact with the database. Yeah, that was only code change here. Next, so type ORM and working with repositories uses something called entities instead of our models. So we create an entity here. We tell type ORM this is going to be an entity that connects to a Postgres database or with a database with this entity decorator. And we let it know which one is its primary key column, and we say it's generated so that it can generate that for us. Whereas before we were using UUID, here it'll just auto-generate that, or it'll auto-generate it. If you don't provide anything here, it'll be incremental, but here we say we want a UUID. And then we also have these other columns in the database: ID, title, description, status. Nice. Oh yeah, PG admin should be working on this computer. I was working on a few different computers. I have a gaming PC and I was like trying to program on it as well. I don't think I did download Docker and PG admin, but I didn't get it working. I didn't try. I was just stuck with this computer. So yeah, this will be our task database. There's probably not any data in it right now.
Does TypeORM have a way to like do those migrations, manage those, time into your code? Recommendations for doing that?
I would have to look that up. Yeah.
I think it does, if I'm recalling this, stuff like the project. The next work on it work, correctly.
Yeah, that's also one part of it. In the entities, we said like auto. That's right. Yeah, it definitely does. Good question. I'll repeat that. So you asked, does it have a way to do migrations? And yeah, for this, we said in our did I not check out the branch? In this, we said synchronize true and auto load entities. That automatically would apply the migrations to the database that we had created. So I didn't have to create those 4 columns. It automatically did based off of the entity that was created. But there's definitely ways you can use TypeORM to do that, do those migrations.
Yeah,
Probably from different files.
I think it has like command that like generates it and it's, oh, actually right there.
Yeah, it has a CLI tool to create migrations. Yeah. Good question. All right. So our entity, but in this tutorial, if you were to go through it, it would use this entity to create those columns. And then there's also the course talks about, oh gosh, was it active record versus data mapper? Basically, from what I understood from this is active record uses your entities directly to update them and save them, whereas data mapper uses a repository approach. And this, they lean towards the repository approach for larger and scalable applications, so that you have a centralized location for all of your methods when you're interacting with a data type. So we created this entity repository telling TypeORM what that repository is, and extending the class so that this task repository has different methods on it that would go with our repository. And this is where the course was a little bit out of date, because there were some package updates that I had to do. Earlier, we had to fix the version of TypeORM, and then in this one, had to fix the version of NestJS to what they were using in the course, because I was getting an error with the repository. So with this commit, application should be running, but we don't have any, what's up?
Get to it.
How did you know that? Or would I have 2 in there?
Go back to the. Go back here to this. 1 and 2, right to the right.
Oh, just because that is the whole point of the Docker instance and the persistent database. It was there when I tested out
I was just
last night.
So they were out.
Yeah.
So you didn't accidentally run it.
All right.
Sorry.
I was like, how'd they get there? All right. But right now with our controller and our services, we're still using the array. So what we end up doing, I think I skipped the commit, but we end up commenting out all of our controller code and commenting out all of our service code so that we can use type ORM instead. And so we'll quickly go through the different methods with type ORM. Accessing Postgres instead of the array. So we also inject our repository. I'll go ahead and check this commit out. And as you probably remembered, okay, as you probably remembered previously, if we're injecting something into the constructor of one of these classes, we are providing it at the module level. So here we use type ORM and say for this feature, add this tasks repository. You'll also notice that we lost our model file. Now, because we have this task entity, we can use it instead of the model. And then for our controller, not a whole lot changes. I did change a little bit here for the params. I went ahead and deconstructed this ID by saying I want the ID param as it comes in. And then we return a promise because type ORM methods will be async. And then we get task by ID, passing that ID on through. And then in our service here, we go ahead and use our tasks repository, this method called find one, which we could provide the ID in order to find the task in the database. We'll go ahead and do that. Get task by ID. So we'll copy one of these. And get our task using type ORM from our Postgres database. All right. Next commit is creating a task, our create task method. Very similar with this as well. We're still using that create task DTO. Again, changing to a promise for our async methods, and then a straight call through to the service. And then in our service, pulling off that title and description. Oh, sorry, this is the repository. Passing straight through the service into the repository, and then creating the task in the repository by adding a method here of create task, where we deconstruct the title and description, and use, instead of this .repository, which you saw in the service, we're using this because we're actually on the repository itself and creating that task. It's interesting to me. It's been a long time since I've done these layers of controller service repository about why we put different things in here. But you'll see in this one, in the previous one, we just used the task repository in the service. Yeah, this .task repository .find one. We use a task repository, one of its built-in methods of find one that type ORM provides. We didn't create a repository method called get task by ID, and then you called find one on that. But here in the create task, because we're doing more, I think in this case, we're creating the task object and then persisting it with this .save task. It's a little bit more, and we wanted to encapsulate all that logic inside the repository. The type ORM delete will look pretty similar to the other ones. Nothing changes too drastically in the controller. And then inside of the service, we go ahead and use this task repository dot remove by finding the task and then removing that found task. There are two different ways to do this. There's also there's a delete method as well that type ORM offers, which I think we actually changed to use the repository delete method. This, instead of finding the task using get by task ID and then removing it by passing the found task and remove method, we just call straight away to this task repository delete. These are two different ways to do the same thing with pros and cons. This way we make two calls to the database. So this one is just a little bit more performant by deleting directly with the ID rather than getting the whole task, telling the repository to delete it this way. So just a little bit more straightforward. All right. And then we have our update status code and get all filters. We'll go ahead and review those and then go ahead and see all this being using Postman. All it good for today. Excuse me. All right, so our task controller, it's update task status. This one still uses all the same parameters coming in. And the update task status service. This one does a similar call to get like we did with the original method that I showed you for delete. We update the status as we want, and then use the task repository to save that task to persist it to the database. And then the get tasks filter here, we actually can simplify this with type ORM where we don't have two different methods like we did with array in-memory version. With this get tasks, this is through the repository. The service should be straight pass through. And we do all this in the repository, again, because it encapsulates a lot of that database logic that we don't want to do on the service level. So in this case, we still deconstruct the filter DTO, and we create a query builder. And a query builder is a cool tool that TypeORM offers for you to create queries like you would on the database, write some SQL yourself. And that's where we do say this query on tasks, on the tasks table, where the task status is the status this is being passed in. And if we have the search parameter, then we do that query where the task title is like the search parameter, or the task description is like the search parameter. And this does encapsulate the lowercase and I think these parentheses are a bit of a fuzzy find where we could find it in the middle of a term. And then we return our query, get many, give me as many as you can find, and returns the tasks. So that's a fun little tool or extension to TypeORM using that query builder. All right, so with this, I'm going to go ahead and just check out main. So we have these two tasks. Let's just go through and do a few things. This first task is open. We can see that it's open when we get all tasks. Okay, this is that remember I said I didn't fix that validation. It didn't persist. So let me fix that real quick. This is not empty. It should be is optional. Okay. All right, cool. So we have both of our tasks. Let's go ahead and update this second task to have the status of in progress. Of course, I have to pick the one that's hardest to type. There it's in progress now. We can get that task by ID. In progress, and just to show that I'm not yanking a chain here, if we refresh this table here, you do see that the second task is in progress. And then we could be like, you know what? We don't like that second task. It reminds us of bad times, so we're going to delete it. Go ahead and see it's gone. And then I only have one to filter with, yeah. Our filters, we can search. Let's go ahead and create that task again. And end on filters here. So we deleted the second one. So let's recreate that. And so we'll have both of them here. And let's just do a search on first. And then we, oh no. Why?
So check on.
Oh, the status is still checked, so it's still in the query
It's still
parameter.
checking.
I'm like, wait, why is it saying the search has to be one of those enums? All right, there we go. We got the first task. So,
Sorry.
thank you for catching that. Yeah.
No, you-
All right, so that is my primer for you all on NestJS. There we go.
What's been your experience with writing automated tests within NestJS, and are there specific libraries that you could sense use in testing?
Yeah, NestJS is like I said, opinionated. So it actually has testing recommendations on how you can test with it, and has testing packages and all of this. It has one of the things that's contentious that we've came across is that it calls it end-to-end testing.
For everything?
No, so
Okay.
it has unit testing,
Okay.
auto mocking, but end-to-end testing is from its perspective. I'm an NestJS application and my endpoint is one end and the database is the other end. So we call it end-to-end tests, but then we get confused between front end end-to-end tests and back end end-to-end tests. But yeah, so it's has a pretty robust testing support.
When it comes to NestJS, why would you personally choose it over a different backend framework?
I think going back to a lot of the features, you know, being TypeScript out of the box, and having that modular framework that you can create scalable. You can imagine adding more and more modules, more and more services, and injecting them into each other. And just that type of modular scalable framework is really interesting for some people that like to have a system and like having a known and repeatable way of developing. We have two backends currently. One is, and it's not even, I don't even think it's an Express application. It's just a node server. And it's like the Wild West. And then we have our Nest application that we're trying to migrate everything to, because it's just a little bit more, patterns that we can follow.
Plus it'd be easier if, you know, one of my places, you can hire a TypeScript developer, then you can have them on the front end or the NestJS backend. Instead of having to like, oh, they're not strong C#.
Right, full stack TypeScript, but it still offers with TypeScript that security and use that people are used to in C# and Java.
Is there any kind of, well, are there any pain points to setting up authentication or any user access in there?
I don't think so. I didn't get to, that would have been the next section of the course was authentication, but it seems like it's pretty straightforward, and NestJS has paths for that as well, different options that you can use as well for it. Wonder where.
Did you mess around with any of the lazy learning?
I did not.
Okay.
Lazy loading, as in if you're getting a lot of data and then just give some value to start with and then give the rest of it.
Like a lot of front-end frameworks have that. Built in sometimes nowadays. Just to load in as it goes instead of just waiting for it all to be done.
Yeah, it's basically deferring it until it needs it.
Yeah,
That's one of the things I've heard. That's might be good at the line, read about it last.
yeah, it definitely has a section on it in its fundamentals. So it definitely looks like it created that with that use case in mind.
I know, it says controller, oh, okay, that makes sense.
Do you know if the CLI tool has any generators or anything?
Yeah, it has to generate different controllers. But after we generated the first controller in the course, there didn't really seem to be a lot of uses for it. Like, how often do you create whole new controllers? It's useful for that. But yeah, that was the only time that we used it.
What's been your experience with a debugging process and logging or observability with it? Is it opinionated on how to do it?
Yeah, there is definitely well-worn paths for logging as well in NestJS, and that also was one of the course sections that I didn't make it to. I should have included that outside of the scope, and I said we could talk about it afterward. But yeah, authentication and then logging were two of the sections that I did not get to. But you can imagine with the liberal use of decorators, that being able to log is definitely something that is you know, you provide my logger and inject your logger in as a dependency. So it's definitely got well-worn paths for that as well.
Very top. Did you dig it all? I saw WebSockets are in that list of things you did. Not in this list. I don't know if the course of WebSockets, but didn't know if you had any knowledge of that aspect of it, or what in this framework was used within WebSockets, how robust that gets, how.
I did not, and I don't have much experience with them in my own, my own experience now. Okay, yeah, it has its own section here.
Yeah.
Mhm. Okay, two platforms, Socket.io and WebSockets, WS.
Yeah, I
two
would think
platforms.
right out of the box being Node, it would have some pretty interesting WebSocket capabilities.
Mhm. Is that something you've had a troubleshooter work with?
I mean, I've messed with WebSockets quite a bit in the past, but I guess I'm trying to liken this to other frameworks that
Mhm.
I'm used to, and so, you know, for example, Ruby on Rails, you had mentioned active
Active record.
active record, yeah. Like that has its own opinionated version of what a implementing WebSockets. So I'm just kind of curious how this introduces that or handles that.
Yeah, it looks like it
pretty
has
straightforward, actually. Yeah.
decorators, with subscribers for events.
Yeah, I dig it. What are you just looking at this because you're interested, or do you think like a next project will be built with this, or do you think?
Yeah, so we do use this at my company. When I was an engineer there, I was a front end engineer and didn't really do much in the back end. And what I did, it was even now I've started to do some coding again, and it's been in the older repository. But we are wanting to move a lot of our older code into the newer area. So it's something that I wanted to be familiar with, so that I could understand the concepts and be able to contribute to that as we start moving things.
And what, I mean, you've kind of mentioned the model layer, the controller, but is there any type of view layer on this that?
I don't know that you say that there is this model view controller, but I think I would imagine most people don't use the view layer and just use this as like a headless API. But it looks like, yeah, that's handlebars. You could return some HTML. So I guess you can do templating in views, have controllers return some HTML. Interesting.
It's a strong suit.
No, I would imagine not so. But you can. It'd be like Django. That's what I was just thinking earlier of the opinionated nod. I was like, yeah, Django is another example of the batteries included opinionated versus. Oh my gosh, what's the? Huh? Yeah, but there's another Python framework. Flask, yeah, that's more build it yourself or DIY.
That's like the adoption of NestJS, among the like JavaScript community, like if you're hiring for people with NestJS experience or anything like that.
Haven't, no. I think I heard about it before I started working at Artera as like an interesting framework to use. But I haven't seen very much of it around, no. And there's even some like some people are like, wow, there's a lot of like NestJS way to do things that we have to learn. So even adoption within the company has at times been a challenge. So
Did you, when you decided to go with NestJS, were there like other similar frameworks that you evaluated? Express, curious.
Yeah, I'd be curious. Yeah, that was before my time. Yeah, so it'd be fun to have been a fly on the wall in those discussions.
Yeah.
Yeah, I mean, the only other big JavaScript framework that I can think of that has as much of this in there would be like Sails. But I don't know of any other fully fleshed out JavaScript frameworks.
I'd imagine that like the skills you gain using TypeScript and the framework, though, it's still it's pretty ubiquitous, the patterns, like I said, between this and Angular, and then also between this, if somebody doesn't know C# or Java and wanted to, this would, you know, give them a leg up in some of the patterns too. So and I don't see it being something that, like, if you know how to do this, that it would pigeonhole you necessarily, I would imagine.
Really big typo already. I remember reading a lot about that years ago. Never messed with it, but it looks really nice.
Yeah.
Was there anything that you found kind of difficult with NestJS, or any problems you had running into it, documentation?
Me personally, no. But I don't have the most extensive experience with it. Yeah.
I would say probably the biggest issue might be it's just very new.
Mhm.
There's not a whole lot of
Tutorial
or
or
just like frameworks, fully
samples.
JavaScript frameworks in that web space. I mean, you can build something in Express, but this takes Express even further.
I think that's just because the hybrid mindset is hard as always. It's like you have to do one or the other. It's an interesting piece to tackle.
Yeah, it looks neat. Looks like a lot of fun. Good. Thank you very much for the presentation.